Hello, we're going to take a look at the review for Chapter 6 test. For the first part, it says simplify each radical. Use absolute value bars when needed. Don't worry about the absolute value bars. So for the first part, it says take the square root of 36. We can put that part onto our calculator. The variables we cannot though. So square root of 36 is just 6. And then since this is the square root, kind of think of it as a 2 there. So for our variables, we can just divide by 2. So we'd have x to the second power, y to the fourth power. And that would be our final answer. And this next one is the cube root of negative 27. So we can put that into our calculator. If you forgot where the cube root button is, go to math. And then it's the fourth button down. Cube root of negative 27. You'll notice it's just negative 3. And then we would divide, our root is 3, so divide by 3, so y to the fourth power. This next part, they want us to multiply them. In order to be able to multiply them, our roots, or our index numbers need to be the same. They're both to the fourth root, so we can multiply these. So we leave the fourth root alone, and then we multiply 12 times our 8. And notice we get 96. And then from here, we're going to want to see if we can reduce this and simplify it. So we're going to do our factor tree, which would just be 12 and 8. Okay. Notice we have 1, 2, 3, 4, 5 2's and a 3. We're bringing them out in groups of 4. So we have one group of 2's, and then we leave the 2 and the 3 underneath because we don't have a group of 4 of them. So we're just going to multiply those. So that would be our reduced final answer. And this next one, they're both square roots, so we can multiply them. So we're going to multiply what's underneath. So 14 times our 7, we get 98. We have 3 x's here, 5 x's here, so a total of 8 x's. When we're multiplying, we add our exponents. And then we want to reduce this, so we're going to make our factor tree for 98. We get 2 and 49, 7 and 7. So we have a pair of 7s, so we can bring out our 7. And then notice this would be the square root, so we're dividing by 2, so x to the fourth power. And then times the square root of, we have this 2 left underneath. So that would be our final answer. This next one, it wants us to rationalize the denominator. We cannot leave a radical in the denominator, so how we're going to get rid of it is we're going to force it to have 2 of everything since it's a square root. So we're going to multiply the top and bottom by square root of 7. So on top we would have 1 square root of 7 divided by square root of 49. Square root of 49 is just 7, so we can simplify that. We can't reduce the square root of 7 in the numerator, so then that would be our final answer. We have no radical left in the denominator, so it is reduced. Don't try to divide those 7's when it's underneath the radical when it's not, so they're not like terms. Now this next one's cube root. We can't go ahead and divide first. They don't divide evenly, so we're going to force it to have 3 of everything. So there's 1 5, so we need 2 more 5s. There's 1 x, so we need 2 more x's. Now notice if we multiply that across the denominator, we also need to multiply that across the numerator. And then we're going to bring out things in groups of 3. So we have one group of 5's, one group of x's. On top, this 9 would be 3 times 3. We have a 5, and an x, and an x. We don't have 3 of anything, so we're going to multiply the 9 times our 5 times our 5 and get 225. And then we have 2 x's, so x squared. Now, even though that 225 is a large number, you would think that we have groups of 3 of something. We do not. We checked that. So then that would be our final answer. Do not try to divide these. Again, one's underneath the cube root and one is not, so they're not like terms. Now this next one we need to multiply, so we're going to go ahead and FOIL or distribute. So we're going to distribute this 8 to both of these terms, so 8 times 9, we get 72. 8 times square root of 3 is 8 square root of 3. Now we're going to distribute the square root of 3 to both of these terms, so we'd have 9 square root of 3, then plus the square root of 9. And then we're going to combine like terms and simplify this. The middle two terms are like terms, so we can combine those and get 17 square root of 3. Square root of 9 is just 3. Then our first and our last term are like terms, so we can combine those and get 75 plus 17 square root of 3. And it doesn't matter if you had these switched, so 17 square root of 3 plus 79 is also the correct answer. Now this next one, notice how it's 8 plus square root of 5 squared. We can't just distribute that exponent, we need to write it twice and then FOIL or distribute it like the last problem. So we're going to distribute this 8 to both terms. Then we're going to distribute the square root of 5 to both terms. Then we're going to start simplifying and combining our like terms. So 8 square root of 5 plus 8 square root of 5 is just 16 square root of 5. Square root of 25 is 5. Then our first and last term are like terms, so we can combine those together. 64 plus 9, or 64 plus 5 is 69, plus 16 square root of 5. This next one, 64 to the 2/3 power. We can just put that into our calculator. So 64 caret to the 2/3 power. Make sure you put the 2/3 in parentheses. And we get 16. And the next one, 49 caret to the 1.5 power. We get 343. For this next one, we have power to a power. The rule is when we take a power to a higher power, we multiply our exponents. So we're going to take 3/4 times 2. I'd make that 2 a fraction and then think how we multiply fractions as top times top, bottom times bottom. So we would have 6 divided by 4, which then reduces to 3/2. And we can just leave it x to the 3/2 power. This next one, again, power to power, we multiply our exponents. So we would have 2/3 times 12, and then 1/4 times 12. And then think top times top, bottom times bottom, so we get 24 divided by 3, and 12 divided by our 4. If we reduce those, 24 divided by 3 is 8, 12 divided by 4 is 3. So that would be our final answer. This next problem, we need to go ahead and solve for x. So notice this radical is by itself, so we want to get rid of it. So it's the square root, so we're going to square both sides. So then the square and the square root cancel out. We get 2x plus 4 equals 36. And then we no longer have that radical, so it's just a two-step equation that we're solving for. So x equals 16, and we could plug that x back in if we wanted to check our answer, simplify both sides, and both sides should equal the same. Now this next equation, notice it's instead of in radical form, exponential form. So if we want to get rid of that radical, or that exponent, we're going to take it to the reciprocal power, so to the 4/3 power. And a number times its reciprocal just equals 1, it cancels out. So we would just have what's left underneath, so x plus 7 equals, and then this 8 to the 4/3 power we can put into our calculator. We get 16. And then we go ahead and solve for it. Now notice for this problem, if we look at our original exponent was to the 3/4 power, always look to see if the numerator is even or odd. If the numerator originally is even instead, then you're going to put a plus or minus 16, and then you'd have two different answers. Since this one was odd with a 3 in the numerator, then we just had one answer. We didn't need that plus or minus sign. Alrighty, the back side of the review. The first problem is in function notation. They want us to go ahead and add the f function plus the g function. So we're going to plug in this f function, substitute in our g function. We need to add, so just combine like terms. So 1 square root of x plus 1 square root of x is 2 square root of x, and 2 plus 6 is 8. These aren't like terms, so that would be our final answer. And then the domain is just going to be x has to be greater than or equal to 0. So all rows, but x has to be greater than or equal to 0. We don't want any negatives because then we have our imaginary solutions. This next one is a multiplication problem. So we take our f function, plug that in, take our g function, substitute that in, and then we're going to have to FOIL on this to distribute. So distribute the square root of x to both terms. So we'd have 6 square root of x. Square root of x times square root of x is square root of x squared. Or notice we have a pair of x's, so it will just end up being x. And then distribute the 2. So 2 times 6 is 12. 2 times square root of x is 2 square root of x. We're going to combine our like terms. So 6 square root of x plus 2 square root of x is 8 square root of x plus x plus our 12. And then from here again we have a radical left in our answer, so x is going to be greater than or equal to 0. Make sure for the domain, if you have a radical left in your answer, then it's always going to be x is greater than or equal to 0. And then if you have a denominator, just set whatever is in the denominator equal to 0. And let's say we would have x plus 5 in the denominator. Then we set that equal to 0, solve for it. We'd get x equals negative 5, so we would just say it's all real, but x cannot equal negative 5 because negative 5 plus 5 would give us a 0 and we can't divide by 0. So make sure if you have a denominator, just set the whole thing equal to 0, solve for it, and then that's going to be your restriction for the domain. For this next problem, they want us to use composition, is what that open circle means. So we start from the inside and we work our way outwards. So they're saying x equals 5. So we're going to plug that into our g function. So we go to our g function. We take 5 squared is 25 minus the 4. So 25 minus 4 is 21. So then now we're left with 21, and we're going to plug it into the f function. So we go to our f function. We're going to plug in 21 for our x. So we'd have 2 times our 21 plus our 3. We're going to simplify that down. Notice we have nothing else to plug it back into, so whatever we get when we reduce this is going to be our final answer. So we'd have 42 plus our 3 is 45. So if we go to this next one, we start with x equals negative 3. We work our way outwards. So then we plug it into the f function first. So we'd have 2 times negative 3 plus 3. We get negative 6 plus 3 is negative 3. So now we have negative 3 again. We plug that into the g function. So negative 3 squared is 9, minus 4, we end up with 5. We have nothing left to plug 5 into, so 5 is our final answer. For those ones, you're just going to get a number for your answer, no variables. For number 19, it wants us to solve for the inverse. So solving for the inverse, you switch your x and your y. So we'd have x equals y squared plus 8. And then the second step, once you switch your x and your y value, is you're going to solve for your new y. So we got to get the y by itself. So we're going to subtract 8 on both sides. We have x minus 8 equals y squared. And then we're going to take the square root of both sides. So then the square and the square root cancel out. So we get y equals plus or minus the square root of x minus 8. Make sure when you take the square root of both sides, you always need that plus or minus sign. So that would be our final answer. The next problem, we want to go ahead and put it in our form that we can use our transformations. So notice right now it is not. So we want to get it in that form. So we're going to factor out to start off with a 16, because a 16 goes into both of those terms. And when we do that, 48 divided by 16 is 3. So we divide both of these by 16 and we get x minus 3 left over. And notice when we do this, then we can now take the square root of 16. So the square root of 16 is 4. So we have y equals 4 times the square root of x minus 3 plus our 5. Now it is in our form that we can use our transformations. So this 4 out front in the a slot means it is stretched by a factor of 4. And then this minus 3 underneath the radical means it goes to the right 3 units. It's opposite of what you would think. And then this plus 5 means it goes up 5 units. And that is our last problem. Please do let me know if you have further questions before we take the chapter test.